This video is on an introduction to chemical reactions, and then on writing chemical reactions from word equations. We'll be working with two guided note papers. The first one just says chemical reaction introduction, and the second one is writing chemical equations. Okay, so we have talked about chemical reactions before. We sometimes have represented them as something like A plus B yields C, okay, where the arrow does in fact mean yield, okay, which another word for that is to make or to create. But in the chemistry world, we do call it, or we do say that the arrow means yields. In this case, A and B would be called reactants. They're your starting materials, so to speak, right? This is review. We should know this. So sometimes I compare a chemical reaction to a recipe or baking cookies where your ingredients are things like sugar, butter, eggs, chocolate chips. Those are your reactants. And then your product in baking, of course, is, in that case, chocolate chip cookies, sorry. And so the product is what you create, okay, or your end results from the reaction. Okay, sometimes there's two reactants and two products. Sometimes there's one reactant and three products. That's what we're going to learn a little bit later on in what makes chemical reactions kind of unique. In the past we've learned some signs of a chemical reaction, that a chemical reaction has occurred. So we'll just list them real quick. We have learned that changes in color, changes in temperature, changes in the odor or the smell of something, all can signal that a chemical reaction has occurred. Bubbling means that we have produced a gas. We have learned that previously. We did learn at one point about something called the formation of a precipitate. And that's definitely a section in this chapter on reaction. So we'll talk in much more detail about a precipitate and what it means to be a precipitate. But those are some signs that a chemical reaction has occurred. What else am I missing? That's pretty good. So that's just a quick review. All right, the next heading on your note paper says diatomic molecules. Okay, well, di is a prefix, and di means two. Okay, so what we're going to learn is that there are 7 molecules that exist in this diatomic form. Okay, that means there's 2 of them. So the most common one that you might be familiar with is oxygen. Okay, so when we talk about the fact that we breathe oxygen, we don't breathe O, because oxygen is a diatomic molecule. We breathe O2. And that 2 is this whole idea of a diatomic. It means there's 2 oxygens stuck together. Now, way back we learned that we could draw a Lewis structure for this, right? And it looks like this was a double bond. It's been a while since we've done that, but so oxygen is one of the 7 diatomic molecules. And so if you're reading something and it says blah blah blah, oxygen reacts with something, it's not O, it's O2. And so there's 7 of them that you have to learn so that when you are reading stuff, you know, wait, that's one of the diatomics, and it's a 2, it's not a single atom, okay? And so the 7 diatomics are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, now I don't have a periodic table with me, but if you do, so hydrogen's right here, but then the rest of them, it goes like this: N, O, F, Cl, Br, I. So I always tell students to remember that there are 7 diatomics. The shape of them kind of looks like a 7. You just have to remember about hydrogen. Okay, so again, if you're reading something, which is going to happen to us in just a couple minutes, and it says hydrogen gas reacts with something, right? You might be inclined to say, oh, that's H. No, it's not. It's H2 because hydrogen is one of the diatomics. Okay, so this is a very important list of the diatomic molecules that you must know, and there are 7 of them. Means they exist kind of in a double, so to speak. All right, and then this last little intro is talking about states of matter. And we have done, of course, we've talked about states of matter, solid, liquid, gas. Okay, we know the states of matter, but sometimes it can be helpful to indicate the state of matter of a reactant or a product in a reaction. Okay, and we're going to get into that later on in this chapter, but so it can be very important for you to know if something is a solid or if something is a liquid in a reaction. And so there are actually 4 states of matter that we work with. The first 3 you know, which of course are solid, liquid, and gas. Okay, the 4th one though is something called aqueous. And what aqueous means is that it's dissolved in water. Okay. So, if something is a solid, it gets a S abbreviation, and I'll show you where this comes in just a minute. If something is a liquid, it gets an L, and it's like a cursive lowercase l. If something is a gas, it gets a G. And if something is aqueous, it gets a Q. So what would this look like? Well, this would look like if you were reading something and it was talking about oxygen gas, right? We just learned it's O2. Then you might see this. So O2 and then in parentheses, a G after it. And that means it's a gas. Or maybe you're reading about water and so you see H2O, but then you see the parentheses with an L because they're telling you that it's a liquid. Okay. So an example of an aqueous substance, sometimes the other word that's used is solution. Okay, but a great example would be like if you took salt, okay, so solid salt, right, which is a solid, I just said that. But if you dunked this into water, right, you and I both know that that salt is going to dissolve in the water and what you have made is salt water. So then all of a sudden, if you're referring to the salt that's in here, you would have to refer to it as the aqueous version of sodium chloride because it's dissolved in water. So what's interesting about states of matter, we just confirmed this. Sometimes things can be solids, sometimes things can be aqueous, and they can be, they can be both depending on the situation. Okay. So here we go. Knowing all of that, we're going to learn how to write reactions from words. Okay, we'll probably do the whole front of this paper, and then I'll leave the back for you to do kind of as practice. All right, so here we go. So it's number 1 says solid metal sodium and water react violently to produce a solution of sodium hydroxide and hydrogen gas. So we just start at the beginning and we say, okay, who is being mixed together? Well, solid sodium metal. Well, sodium is just Na. That's easy. They told me it was a solid, so I'm going to label that it's a solid. And then they tell me that that sodium reacts with water. So what we do is we put a plus sign, okay, for the sodium. It's going to react with water. We all know water's formula is H2O. Water is a liquid. And then here comes my keyword, to produce, which is your blinking red light, so to speak, that means it's time to do the arrow, okay? Because remember, to produce, to make, to yield, to create. So what do we make? A solution of sodium hydroxide. Now this is where we have to go back and really remember how to write formulas. Sodium hydroxide is an ionic compound. It's a combination of the sodium ion +1 and the hydroxide polyatomic ion -1, right? Equal charges. So sodium hydroxide is NaOH. They told me it was a solution, which means it's aqueous. Now, I just wrote this to help us. I'm going to get rid of it. Okay. And then hydrogen gas. Well, we just learned hydrogen gas is one of those diatomics. So H2 gas. And you just did it. That's the first reaction that we wrote. So that's exciting. All right, let's keep going. Number 2. Hydrogen gas and oxygen gas react to form water. So, start with my reactants. So, hydrogen gas, it's H2. And oxygen gas, so oxygen's also a diatomic, so O2. React to form, that's your hint, react to form water, so H2O, liquid. And you have written a second reaction. Now, this is normally where it comes up, so I want to address it now. A lot of students get to this part, they write this reaction and they say, what happened to the other oxygen? How did I lose an oxygen? So if you're looking closely, I have 2 oxygens on this side and only 1 oxygen on this side. So that is very bothersome to us, and we're going to learn how to fix that, but that's a story for another video. Okay, that's too much to combine all into one. So for now, we're going to pretend like it's not bothering us, and we will come back and deal with that later. All right, number 3. Solid aluminum metal reacts with oxygen gas to produce solid aluminum oxide. Okay, so solid aluminum metal, that's just aluminum, reacts with oxygen gas, so O2, to produce solid aluminum oxide. Now you might get excited and write ALO and think you're done, but aluminum oxide is ionic and I need to equal out my charges. So aluminum's charge is +3, oxygen's charge is -2. And so this is the one where we need Al2O3, right? So that I have a total positive charge of 6 and -6. And they told me that was a solid. Okay. So the whole idea of ionic formula writing and equaling out charges, that's huge in this, and you have to do that correctly. So what a review this is for us with that. All right, number 4, a solution of iron 3 chloride and sodium hydroxide react together to form solutions of both iron 3 hydroxide and sodium chloride. Okay, so iron 3 chloride, well, that means iron's charge is +3 and chlorine is -1. So my formula will be FeCl3. And they tell me it's a solution, so I know that that's aqueous. And sodium hydroxide. Well, we just had that. Sodium's +1, hydroxide's -1. So this is NaOH, also a solution. To form solutions of both iron 3 hydroxide. So that means Fe +3, OH -1. So Fe, remember I need parentheses here, also a solution. And sodium chloride. Sodium's +1, chlorine's -1. NaCl, also aqueous. All right, number 5. And at any time you can pause this and, see if you can do these on your own. Okay, number 5. When heated, baking soda, and they just give you the formula, decomposes to form sodium carbonate, carbon dioxide, and water. All right, so when heated, baking soda, here we go, NaHCO3. Now, it doesn't tell me it reacts with anything, it just tells me that it decomposes. So this is the first reaction we have seen that only has one reactant, okay, and it's the baking soda. Decomposes to form sodium carbonate. Okay, so sodium +1, carbonate is a polyatomic -2, so I need 2 sodiums. So Na2CO3. They don't tell me a state of matter on that, so I'm just going to leave that off. I'm probably pretty sure that baking soda is a solid. So sodium carbonate, carbon dioxide, that's a covalent compound, CO2, which we know is a gas. And water, of course, H2O, which we know is a liquid. Okay, I will tell you this. because it's kind of interesting. Anytime you have a reaction that says it's heated, there's a way to denote that, and it's with a little triangle, which is like a delta, the Greek letter delta, over top of the arrow, and that means heat. Okay, so just something additional to learn. All right, 2 more. Number 6, iron 3 oxide reacts with hydrogen gas to produce solid iron, metal, and water. Okay, iron 3 oxide, so Fe plus 3, oxygen minus 2. So this is going to be Fe2O3. They don't tell me state of matter on that either, so I'll just leave it off. It reacts with hydrogen gas, that's H2, to produce solid iron metal, well that's just iron, and water, H2O, liquid, done. And not last but not least, number 7, phosphorus reacts with oxygen gas to produce solid tetraphosphorus decaoxide. All right, so phosphorus, that's just P. They don't tell me a state of matter either. Reacts with oxygen gas, so that's O2 gas, to produce solid tetraphosphorus decaoxide. Here's one of our first covalent compounds we've encountered in a little while. So tetraphosphorus, that means four phosphorus atoms, and decaoxide, so 10. So O10, and they told me this was a solid. And there you go. So that's the intro to reaction writing. And I would recommend that you now take some time to attempt the ones on the back, okay? And see if you can write the reactions from the word equations for those reactions on the back.